If you've ever rubbed a pain relief cream on a sore muscle, you've basically used some of the most advanced science out there without even realizing it. We totally take it for granted, but have you ever wondered how that cream actually gets the medicine through your skin to the part that hurts? Well, let's get into it, because the answer is this fascinating battle between high-tech medicine and our body's amazing natural defenses.
So yeah, that's the big question for today. How in the world do we sneak powerful medicine past the biological fortress that is our skin? It's a mission that's going to take us from some basic biology right to the absolute cutting edge of nanotechnology.
And take a look at this. That fortress idea is no joke. Our skin isn't just one simple layer, it's this incredibly complex organ. You've got the epidermis on top, the dermis down below, but for any cream, the real challenge, the main boss, is getting past that very first line of defense. So let's zoom in on that.
All right, every good story needs a villain, right? Well, meet ours. Its name is the stratum corneum. This is the outermost slice of the epidermis, and believe me, it is ridiculously good at its job of keeping things out.
And get this, it is astonishingly thin. We're talking thinner than a sheet of paper. But that tiny, tiny layer is our body's main barrier. It's what stops all sorts of harmful stuff from getting into our system every single day, which is great. Except it also stops the helpful medicines we want to get in, unless, of course, we get clever.
This brick-and-mortar analogy is honestly the perfect way to picture the stratum corneum. You've got these tough, dead skin cells. Those are the bricks, and they're all held together by this fatty matrix of lipids, which acts just like mortar. So any drug trying to get through has two options. Either try to smash through the bricks or take the long, winding road through the mortar. So how do we get past that wall? This is where the heroes of our story come in. Non-steroidal anti-inflammatory drugs, or, as you probably know them, NSAIDs. These are the workhorses in so many pain creams, things like ibuprofen or ketoprofen, and their whole mission is to breach that brick wall and shut down pain right at the source.
So how do they actually work? Well, way down at the molecular level, NSAIDs are basically bouncers. They find these things called COX enzymes, and they block them. When those enzymes are blocked, your body can't make something called prostaglandins. And prostaglandins are the little chemical messengers that scream pain to your brain. So no prostaglandins, no pain signal. It's really that straightforward.
Now, you're probably thinking, okay, but why not just take a pill? And that is a great question. This table shows you exactly why. When you swallow a pill, that drug goes everywhere, all through your body. That can lead to side effects in places like your stomach or your kidneys. But with a cream, you get a super high concentration of the drug right on the sore spot, and very little goes anywhere else. It's targeted, it's more efficient, and it's often a lot safer.
Okay, so let's get back to that brick wall. A drug molecule basically has two choices. It can take the intercellular route, which is the long, scenic path snaking its way through the mortar between the cells. Or it can try the direct transcellular route and just try to punch straight through the cells themselves. And trust me, neither one of those is an easy journey.
To actually get past this incredible barrier, scientists have come up with a whole toolkit full of really ingenious methods. These are the secret weapons that make your pain relief cream actually do its job.
And all these strategies really fall into two main camps. First, there's what you could call physical force, using some kind of energy to literally push or pull the drug through. And second, you've got chemical disguises, basically camouflaging the drug in a clever way so it can sneak past the skin's defenses unnoticed.
Let's start with the physical stuff. Iontophoresis. Sounds complicated, but it's really just giving the medicine an electrical push. By applying a super low, totally safe electrical current, we can use that basic principle of opposites attract to drive charged drug molecules right through the skin's barrier.
Next up, sonophoresis. This one uses low-frequency ultrasound waves to gently vibrate the skin. That vibration literally jiggles the mortar, those lipid layers, and creates these tiny temporary pathways for the drug molecules to slip right through. Pretty clever, right?
And then there's electroporation. This method is even more direct. It uses short, little pulses of electricity to create tiny, temporary pores. Think of them like microscopic doorways that open right up in the cell membranes. The drugs can just walk through these open doors before they snap shut again.
Okay, now for the really futuristic stuff, the chemical disguises.
You should think of these like a microscopic delivery service, using little nanotech Trojan horses to carry their precious cargo deep inside enemy territory, our skin.
The real stars of this show are called vesicles. These are just tiny bubble-like packages made out of lipids, which is the same stuff our own cell membranes are made of. They can wrap up drug molecules inside, protecting them on their journey through the skin.
But here's the key. Not all vesicles are created equal. The older versions, called liposomes, are pretty rigid, and a lot of times they just break apart when they hit the skin's surface. But the new and improved ultra-flexible carriers, called transfersomes, these are a total game changer. They're so bendy and deformable, they can literally squeeze themselves through gaps between skin cells that are way, way smaller than they are.
Another brilliant invention is the solid lipid nanoparticle, or SLN. These are tiny particles of solid fat that carry the drug. But here's the genius part. They do two jobs at once. When you put them on your skin, they form this thin film that traps moisture. And that hydration makes the skin more permeable, basically creating a perfect, softened-up pathway for the drug to get absorbed.
So this comparison really hits the nail on the head. You can see the huge difference, right? The incredible flexibility of transfersomes lets them penetrate deep into the skin for what we call transdermal delivery. Those rigid liposomes, they're still useful for sure, but they're much better for delivering drugs that you want to stay right on the skin's surface.
So, with all this amazing technology already being used, you have to wonder, what's next? Well, the future of getting medicine through our skin is looking even more incredible.
Say hello to the nanobubble. Yep, that's right. These are microscopic gas-filled bubbles suspended in a liquid. The latest research suggests that when these nanobubbles get to the skin, they actually expand the outer layer, essentially prying the door wide open for the active ingredients to flood right in.
And just look at what that means in practice. This chart shows the results from one study. A product that normally took 3 hours to get through a lab-grown skin membrane made it through in just 30 minutes when it was paired with nanobubbles. That is a 6-fold increase in speed. Absolutely wild. So why does all this tech matter to you and me? Well, it means we get better, safer pain relief, targeted right where we need it. It means we can avoid a lot of the systemic side effects that can come from taking pills. It's a perfect example of how mind-blowing science is hiding in plain sight, making the products we use every single day smarter and way more effective.
You know, it really leaves you wondering. We started with a simple cream for a sore muscle, and we ended up at the frontier of nanotechnology and bioengineering. As we get even better at mastering the art of bypassing our own defenses for our own benefit, what's next? What other incredible treatments might we one day be able to just rub right onto our skin?